I'm pinning commit over the IAM. Let's wait for one more minute. Okay, let's start. Last week was the national holiday in China, so I barely working on the Crimson, but aside from that, I was preparing for the slides for the Silicon in the next the week after next week. That's pretty much what I have. Vitek.
Last week in Poland was a long weekend, 2 holidays, but for a week before. And yesterday I was working on 2 items related to Crimson. First one is, of course, the write path. Here is a work in progress pull request. It basically writes should be testable with Rados bench. 2 missing parts there is distinction between write and writeful operations, and it would be also nice to handle set alloc hints, if I recall correctly. I have a patch for the last thing. The second item is creation of it's support for creation of PGs. With the write path branch, it's still necessary to use classical OSD, but just to handle creation of PGs.
Yeah, I'm actually doing that now for what it's worth. That'll come in with the rest of the pairing choose.
Okay.
You know.
Do you mean are you working on PG creation?
Yeah, I mean you kind of need to do that for the process notify messages. So I'm kind of doing that part too. Though if you have a workaround, by all means go for it.
Okay. Well, the current state of it is that I'm almost handling the creation. I'm just in Crimson we have OSD do peering event that takes PG peering event wrapping PG create info. I'm just short circuit it with and handling PG create info directly, and I guess it still can be useful.
That sounds right to me. That's right.
Okay, I'm just bypassing the machinery in do peering event. I have a method taking PG create info. Normally it should be called by peering machinery, but at the moment it's called just by the handler of OSD create second.
Yeah, ordinarily it would get called in 2 places. It would be called in do peering event in OSD, either when you get an MOSD PG create 2 message from the monitor, and we're not going to bother
Sure,
supporting view all
sure.
at once, why bother? Or when you get a notify message from the primary. Those are the two places. So it sounds like
Okay.
you've got it set up right though for you. So like, yeah, go for it. That sounds great.
Cool. It sounds really is reusable altogether with your work. Cool.
Yep. I'll just
Perfect.
adapt it when I get to it. Is your stuff
Okay.
merged? If so, I'll rebase on it.
I will focus on creation. It will be ready quite soon, I think. It's pretty straightforward.
Cool.
Great. Good. I'm wondering if you could rebase your PR to 278.33 against master, and as we discussed yesterday, so we can get it merged because it's pretty much
Okay.
correct.
I have a branch. I have your branch rebased with I added the commit. I will just push it and let's finish it in another commit, in another PR. Let's merge it as is. What do you think?
Yeah, it sounds great.
Great.
That way I can rebase on it.
Cool.
Yeah.
And you don't need to worry about the notify thing, by the way, if you're only doing one OSD. Like,
okay.
The create message is the only thing that matters.
Okay, so I'm pushing the rebase. I'm pushing your rebase of the right path, adding one commit for the linking error.
Yeah.
Sounds great.
Have you by any chance done the thing where you changed vstart to do whatever needs to be done to start up some directly?
We already have a -- Crimson in.
Okay. So once we get the PG creation and peering part working, it should just flat out work.
Yes.
Sweet.
That's
okay.
That's
what
the
I wanted to do.
idea.
That's what I was going to have to do tomorrow. Cool.
A question about it. I'm still not able to get things to work. You send me a list of commands to start trying the Crimson OSD. Now I get to the point where it runs, but it doesn't seem to perform anything. It doesn't crash, but it doesn't seem to run. I'm using the tip of the tip in Git. Do you know do you have any clue, or shouldn't I use this version?
I was able to get into your situation in two cases. First one is lack of the one-liner for the PG peering. Do set active, something like that. One-liner that is a part of the procedure. Enforcing the state of PG to peered.
Honestly, it would be fine with me if you just added that patch. Maybe as a config variable or something, just to prevent people from having to hand apply the patch.
Yes, we can edit the patch in your PR as a separate commit. We can remove it once.
Yeah, we can fix it once it actually works.
Yeah, in shape.
Okay, because I was trying to debug my system without really understanding it, and I'm still working on it. But if we have a stable version, it would be.
I think some kind of an experimental config variable would be the best option, because there's going to be a period between when Crimson pretty much peers and when it actually works properly. And in that intermediate period, it might be nice to have an escape patch, just in case someone's doing benchmarking and they genuinely do not care about a bug in peering. They just want to benchmark one OSD, right? Because for instance, I'm going to have peering working, but not recovery or backfill. So there will be conditions under which a cluster is unrecoverable. So it would be convenient if there were a way to just bypass the whole mess, even once we have the peering stuff merged.
Okay, I can add an option for this hack.
Yeah, that's what I'm thinking.
Can I ask a question, General? The SeaStor. Can you tell me what's the purpose of having it instead of memstore? What I'm reading in the code it doesn't look different. It doesn't look SeaStor in the way it's written.
That's a good question. Actually, SeaStor pretty much duplicates MemoryStor. The third difference is that its interface is a featureized one, which we try to pretend that the 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 result, for example, the object we read from MemoryStor is an async procedure, unlike that of a MemoryStor.
Mm-hmm.
The SeaStor is the way how we want to shape featureize the object store. We want to use it to define the interface, how we talk to a featureized object store. That's all. Without
it's a web store with the interface, with async interface duration.
And the argument is that memstore is too simple to bother refactoring to have two interfaces, basically. It's not worth the work.
Correct.
Yeah, exactly. That makes sense to me.
And it's usable now for, I see, for simple transactions. What is the status?
Of what? Sorry?
What is the status of the code of Cyan store?
Well, I
pretty
believe
much
it's
copy the memory stores, so it's stable.
Well, I mean, to be clear, it doesn't write to disk, really. So in that sense, it's a little bit.
Yeah.
I don't know if production ready is the right word for that, but
no, I wasn't expecting it from MStore.
And another problem of a SeaStor is probably that how we return how we do the error handling. That's one problem that we can and what Riddick has tried to overcome with his patch in his PI mission in the chat.
The concept is we'd like to be able to use the future exceptions, but they're too slow.
Yes.
Or we can't use future exceptions without using C++ exceptions. That's a bummer.
SeaStor actually tries to use exceptions, STD exceptions-based things, but instead of throwing, it has a concept of a failed future.
I really like it. It's really convenient to code with, actually.
It's really cool, but the future class has some methods for handling the stuff, for handling particular exceptions. Like, for instance, there is future handle exception type. It inspects. It's pretty smart thing.
Okay.
Yeah, when it comes to handling particular type of exceptions, it rethrows an exception held by failed future. So it still uses the pretty throwing machinery. Guys, it's really nasty thing because throwing and because of implementation of exception handling it really depends on a particular compiler, on particular libgcc stuff, all that crazy things. Guys from Styla, from Styla made absolutely crazy hacks inside SeaStor to optimize handling of exceptions, because in older GCCs, well, maybe even in GCC 7, throwing an exception needs global locks. It's crazy, but there is a huge comment in core/exception_hacks.cc in SeaStor. It's really nasty thing, and I guess we could try to optimize that. I believe.
But the reason for all of that crap is for runtime inspection of the exception type, right? That's the whole point.
It's not standardized. We are already the patch for the right path tries to use some internal not standardized method that is available on
no, I know, yeah, sure.
On the GCC's implementation of STD exception PTR. I don't actually want runtime inspection of exceptions. If we could template the error type separately, so you template the return type, right? So if you could give it two template types, one of them is the return type, the other is the exception type. There are several libraries that work like this. Then you don't have any of this problem. It's not an exception anymore. It's just a type.
You can do the very same on-failed handling stuff because that's not special. That's just different threading of which continuation you call. Do you think they might be open to expanding the way futures work a little bit? Because we don't want to be doing runtime inspection of types for handling.
Well, I believe the runtime
really
inspection is made properly. Is much cheaper than throwing and that rethrowing exception pointer.
No, I'm saying we should just never do that. So you could imagine instead of returning T, return T or error type, right? Where error type
something
is
I see. There was some time ago. There was a proposal for maybe types in C++.
C++ has them. Like you can do that, or Boost does, whatever.
Yes, there is SG14 tested for Boost outcome.
Yeah, so we can totally just choose to always return futures of a type that also is capable of representing an error. That would work. It would be more convenient if it were built into the future type, though, because the way the continuation threading works is nice. You could say something like, on success, do this, on failure, do this. That's really nice. Like, it's very ergonomic. It allows you to bypass a whole bunch of,
I see. But it means
so that would be nice. We don't have to fuck around with exceptions at all. But it would be more convenient if it were built into the futures library.
Sure, but if it's not if it's not a part of future library,
it probably generalizes what they have. So, sorry, go ahead.
We would end with 3 different types of handling errors. One is even now in SeaStor we have 2 methods. One is throwing an exception. Second one is returning a failed future.
Yeah.
And third one will be returning a future storing maybe type of T.
Right. So I'm suggesting we should just have the first 2, but the second one, instead of returning a failed future, doesn't have to be a standard exception. It could be a second template type that could be standard exception if you don't specify, or it could be something else. Like an error code.
I think we could follow the convention of Golang, which returns two variables, one to indicate if there is an error, another is the result of the call.
If we have to do that, we can do that. But the advantage, so if you've ever read Go code, there's this irritating pattern they have where they have to do the error handling code sometimes after like every function call, especially if it's the same error handling code. But if you bake it into the futures library, then at the end you just add an on-failed handler that will just handle wherever in the callback chain you got a failure, it would percolate through to that failure as long as the type didn't change. A lot like an exception, but without the overhead of it being an actual exception.
Isn't that exception pointer implemented properly?
Yeah, so what I'm saying is we could probably change SeaStar's futures to be what they currently are if you don't specify an error type, or a special type if you do, in which case it doesn't do any of the exception stuff, and you have a different method for dealing with it that is the one that's always present. In other words, we could talk to them about changing the way future works to behave the way it currently does if you don't tell it to do something different, but also to do something different, because I suspect that it's a superset, and it will be pretty easy.
So you are thinking about a future caring about basically 2 different types. One is, of course, the result, the promised type, but second one is a type responsible for handling errors. Currently, in current implementation, the second one needs to stick to std exception _
Yeah, and that's what the default would be.
You would like to generalize it to handle to have a type of error signalizer configurable.
Of whatever you want it to be, yeah. For us, it's probably an int or something, yeah.
I see.
That way, we don't have to pay we just don't have to interact with the C++ exception system at all if we don't want to, but we still get the ergonomics of future-based error handling, which is nice.
And you prefer this to just changing the value type for us, making it something like outcome or expected, or whatever, something
Just
that
a little bit.
carries.
Just a little bit, because when you're actually writing the code, so let's say you want to do like a chain of, you're reading an object info off disk, right? So you ask the store, please read this attribute for me off of object whatever. Then you do some transformations on it, and you eventually return an object info, right?
Yes.
If you need to do, if you represent it in the return type itself, you have to propagate that, oh no, something went wrong exception all the way through that chain.
But you just think that
if you have an on failed, you just add one on failed at the end. That just normalizes it back to whatever you needed to return out of the interface. We can totally do it just in the type part if SeaStor doesn't want to mess with it, or if ScyllaDB doesn't want to mess with it. That will work. It's just less convenient.
It's just it's a major change, a new concept instead of using one that is currently used.
No, it's the same way the Rust library works. It's the way other stuff works too. It's really quite normal. Haskell's error handling works the same way. ScyllaDB chose a strange way of representing futures, actually. They should have deliberately represented both the error and the value types. That's more normal.
Okay, but just to mention that if we do it as part of the value, you simply start the future function with if has value, do something. Otherwise, just
yes, I know. It's that if it chains, it's that you generally deal with a chain, right? So let's say you need to do a sequence of dependent I/O operations, but the first one fails. Now every one of those has an if block, and you have to remember to propagate the error from the previous one back through the next one.
Yes,
that's the only bad part. Like it will totally work. It's just less convenient. That's the exact pattern that exceptions were designed to avoid, in fact.
Yes, you're right. But
arguably poorly, but that was the idea.
Okay, and another question, do we wait? We can't probably wait for SG something 20, C++ 20 something.
No. This is a change not in exceptions. It's a change in ScyllaDB's future implementation, which we can just patch ourselves. Like we don't.
The question is how much we could squeeze in comparison to well-tuned STD exception PTR based handling.
I thought you said there's no way to avoid the global pointer idiocy.
Well, it's. I'm not sure whether we are thinking about the same.
Okay.
STD exception thing as STD exception pointer can be actually the most pain from the current thing, from the current shape of exception handling in SeaStor comes from rethrowing an exception.
Yes. Yep.
But it doesn't really need to be thrown at all.
Okay.
Instead, you could just compare some. Basically, you could compare a VPT. The important thing is to discriminate between types of exceptions. Even now in SeaStor, we could do very cheaply the check whether we have exception or not. It's very cheap. The pain comes from discriminating between types of exceptions. That's the reason why SeaStor rethrows the exception PTR stored in a future state.
Yeah, no, I got it. That's because it's the one way C++ gives you to introspect the type of the dynamic.
Of course, but if there is a second way, better, cheaper one, GCC offers,
we probably do want to be able to know.
1 second. Okay, got a link. Here it is. That's the entire idea.
Standard logic error is a subtype of standard exception. Yeah, okay.
The idea is adaptable to the current implementation of future handle exception type. This is, I believe that's the reason why Styla folks implemented the very nasty hacks for exception handling. We could avoid doing that.
And CXA exception types, this is RTTI? Is this just always available if you have RTTI enabled? Is that what it is? Maybe not.
Sorry, Sam, could you repeat, please? I got a terrible glitches.
Oh, yeah, sure. No, I'm asking, is CXA exception type, is that always present if you have RTTI enabled?
It's not. It's not guaranteed by standard. If we are on
GCC.
Able, yes, but we could just deduce whether we have this thing. If not, fall back to the old way of rethrowing exception pointer.
Yeah. And you would then change the internals of SeaStor to do this check for us.
Yes.
Okay. I see.
Question. Yeah. Exceptions currently carry a heavy weighting, a heavy price in size, spreads, and performance, even if we are not doing too much in rethrowing.
Yes, creating an exception is another way. It's another pain. Currently, C++ offers make exception pointer or something like that has that involves some atomical ref counting, but I'm not sure whether we are obligated to use this method. If not, if we are able to create exception pointer outside of that, well, maybe it should be better. But definitely,
this is
another thing to verify. Creation
but
of
at the end of the day, this is making something dynamic that doesn't need to be. Like we could be 100% sure at compile time what the error type is.
Yes, and that's why we have in C++ the suggestion to modify the way to have static exceptions. It's not part of the standard yet, but it will be probably.
Well, that's yeah. Sorry.
Yeah.
Go ahead.
HabSat suggested it, and it has a lot of support from real-time people. I think it will be part sometimes in the future, part of the language.
Well, to be clear, we don't even want the stack unwinding part of exceptions. Like no part of exceptions really do we want.
Okay, so yeah. I think the best idea would be to go with propagating the errors somewhere, either through future or value. Either way, but
that seems the most direct to me. Unless, I mean, I don't know. I guess I don't feel that strongly. Seems like Redux solution could be made to work, but since we have to change SeaStor anyway, it seems better to clean up the future type so this isn't a problem.
It's still far from being perfect. The question is about the ratio between changes and the benefit, I guess.
Well, remember, we can do the value thing and just tolerate a little bit of annoyance for free. We don't have to change SeaStor at all for that.
That's true.
We just adopt a convention for what we return from IO types.
Yes.
And we just use it.
But in that way, we will shoot with our own convention for error handling.
Everything has its own convention for error handling.
Yeah.
So I'm kind of okay with that. Even this exception thing is its own convention for error handling. Like even our choice of how to encode our errors in the exceptions, that's
yes,
convention.
But in total,
it's one enforced by the compiler, which is nice.
it sums up. It means that you need to stick. You need to be aware about conventions coming from SeaStor. Then we would need to also be aware about our own convention for error handling. It means more conventions, actually.
Yes,
So
but
you're
better
worried that
performance.
we will use an IO library from SeaStor that works one way, and we will have to convert it to working our way.
Exactly.
Are we going to use an IO library from SeaStor that does that?
As network, for instance.
Okay.
Yes, I think we are using the IO library from SeaStor.
That is a valid point. That's a pretty strong argument to get them to not do what they're doing.
Guys,
Then we only
Okay.
have one convention, the right one.
guys,
Yeah.
what do you think about scheduling a small session in face-to-face conversations about error handling, dedicated to error handling?
Oh, I know. I
At
think we should
Barcelona.
definitely do that. Yeah, no, that's a great idea. Yeah,
In Barcelona?
I'm
Yes.
I'm on board. I have a lot of things I want to talk about actually.
Cool.
Yes, we.
I'm not sure I'm actually going to even bother to go to KubeCon so much as track you guys down and talk to you.
That's a good idea because that's my idea too.
Yes, I will send a mail to list some of the topics we will discuss. I have something in my mind also.
Cool. It will be perfect to have a list of items for brainstorming.
Exactly.
Oh yeah, that's a good idea. Does someone want to add or create a document or like a Google? What's the way people
Okay,
share?
I will send a Google Doc shared with
Okay, cool.
with you guys.
And a good idea
Perfect.
might be to add phone numbers and way to communicate.
Yeah.
Okay, I will
Actually,
do.
I'm not sure if my phone number is going to work. We'll see.
Last one.
When will that discussion happen?
What's that?
I think it would. When will be the discussion happen?
That is a good question. I mean, I haven't seen a Saturday or a schedule for anything happening on Saturday, although I do know things that are happening. Or I know there are meetings, but I don't know when they are or what they are.
I'm arriving Saturday afternoon.
Well, me too.
I think
Sorry?
now send a mail regarding to the face-to-face discussion time. But I will figure out. I will find the mail in the inbox and send you guys our meeting schedule to see if we can consolidate the time. Okay. Honan, anything from your side?
Not much. I'm reading code mostly. I'm trying to go through logs to see what I see in the code, how it runs in the logs. Hopefully, I'll get to write things during this week. It's a long weekend now. I'm on a day off now, but I hope to get something. I'm not sure if I get something done before the conference, but I try. I don't have many work. I have one work day until then.
Okay, cool. Sam?
So I got the big pile of peering state patches in last week, so that's good. So now I'm wiring it into Crimson. I've got, well, I had to spend some more time separating out interfaces for a few more things on the OSD side, but it's much smaller. Hopefully that'll go up tomorrow, that PR. For Crimson, I've got the way peering state works is you've got like a bunch of, peering state itself has a bunch of methods for giving it events and such, but it also has an interface the next level up has to implement so that it can send notifications back up and ask for things like, please send a message for me, that kind of stuff. So I've got almost all of those. Well, I've got the ones of those implemented that I care about. I'm not obviously doing any of the ones related to recovery or backfill or scrubbing or scheduling or any of that nonsense because that's not implemented yet. So that'll be later. And what I'm doing now is I'm wiring up the last little bit for PG creation and notify handling. So with luck, tomorrow I'll be able to start crashing it, which will be progress of a sort.
By wiring the PG creation message, you mean by wiring up the PG creation message, you mean you're working on the Crimson OSD side, right?
Yeah, there's just like the monitor message that says, please create this PG for me. We talked about before, MOSD PG create too. So
Okay.
that and notify both do the same thing. They trigger the creation of an of a PG, and then an event gets shoved into the PG. So once that works, I think I'll have everything for a cluster to come up and peer, which will be good.
Okay.
After that,
Okay.
we'll have to figure out how to make recovery work, since there's no way to make it actually tolerate the death and resurrection of an OSD otherwise. So that'll be the next thing.
Okay.
And we won't be bothering that, or we won't be borrowing that from classic OSD, so we'll have to actually write it. That'll be slightly more work.
Okay. Anything?
It's one of the things we'll want to talk about in Barcelona. And also I want to talk about how we want to do like scheduling of events, not just both peering events and op events, in a way that doesn't run us out of memory if we get behind. So I want to talk about throttling basically.
So I don't get you.
Well, there's this basic problem that like when the PG isn't prepared to deal with IO, it has to just wait, right? So I don't think it's a good idea to just build up non-functioning futures in the reactor. That seems bad.
Okay.
I'm guessing, although I could be wrong. Maybe it's super efficient.
We need to introduce a machinery to apply the back pressure to the consumer.
Both that, but also I'm guessing that we want to limit the number of futures that are ever active in the reactor. Like, what if we think a future is going to be inactive for tens of seconds, that probably isn't a good thing to just leave in the reactor as a not ready future. We probably want to pull that out as its own thing. Maybe put it, or like stick them all in one not ready future or something. I'm not sure. We'll have to talk about it. The way SeaStor works gives us sort of a lot of options. So it's just sort of a sitting down, talking about the options, and kind of working out what the trade-offs are.
Yeah, we can explore the options.
Is there a standard way we handle long acting operations? Tens of seconds operations?
Well, it's not even that they're long-acting operation. The problem isn't that it's long-acting. It's that it should be a super short operation that can't make any progress right now because of something that could take 1 to 10 to 15 seconds. And there will be a lot of them that all do the same thing because they're all IOs pending on the same PG that can't make progress right now. So usually leave them in a queue or something, or in a list, a wait list, a la the kernel, who eventually get dumped back into the run queue once they're ready to run. But we don't have a concept like that in Crimson just yet. So we'll want to decide what we want that concept to look like.
Okay.
Basically, what do we want Crimson to do for a run list, or a wait list rather?
Yeah. Yingxin?
Okay, so currently I think most of my ideas of optimizations are evaluated or pushed to upstream, and I have some initial data of how a comparison between Crimson Messenger and I think Messenger, and most cases the Crimson Messenger is better or much better than async Messenger, especially when the block size is larger. It could be 2.7 times better if block size is 1 megabyte. And I think this is the first thing. And second thing is I have sent out a PR to improve the SeaStor prefetch size, because when I test it with NIC card in two servers, it seems that the performance is not good. So I changed the prefetch size of the SeaStor input stream and it seems the result is much better. And the second one is I don't want to introduce another settings to set the prefetch size. So I think that size can be adjusted dynamically based on the last return size. So this is my current implementation, and it looks good in our cases from the 200K to 1 megabytes. I measured all of them, and it doesn't seem to introduce some bad performance. And the third thing is I also tried to batch in the read pass here. This PR. This PR is to collect all the read buffers in a queue, and then we can dispatch all of the buffers in a single task to dispatch them all. But it seems it doesn't bring too much benefit because we are introducing another queue in our IO path. In most of cases, it will hurt our performance, and it's a very special case. If we have 4K block sizes, it will see a little better performance if we increase the prefetch size. So I think I can just keep it as a do not merge PR here. So I don't think we need to merge that. So in the following weeks, I think I'm going to write the slides for Sapphire account. That's all from me.
Xin, have you ever tried to talk to CLDB guys with regarding to the SeaStor PR?
Yeah, I will try to
adaptively change the prefetch size.
Yeah, I will try to send email to CLDB community.
And meanwhile, I will just pick your change into our PR and add an updated submodule of SeaStor.
Okay, thank you.
Okay, anything else, guys?
One small thing, I'm sending, I hope, yeah. This is from an email someone in SG14 wrote about size requirements for error handling. I think it's a good work that was done. Should be considered before we discuss error handling and exceptions. You might want to take a look at it. You got it?
Reading read, thanks.
Sorry?
Got the link,
Thank you,
thanks. Reading read.
Okay, thank you, guys. Talk to you guys next week. Have a good night. Have a good day.
Bye.
Thanks. See you.
Yep.
Bye.
See you, right.